Hello everyone, and today it is a video number 3 of our daily solution of UPSC Civil Service mains paper of mechanical engineering. And today we will solve two questions. One is from refrigeration air conditioning and one is for power plant, gas turbine power plant. So first let's start with RSC question, that is an ammonia vapor compression refrigeration system works between the temperature limits. It is temperature limit given, dry at the end of the compression and no undercooling and no further throttle at lower temperature, and find the COP of the machine. Use the properties of ammonia. So here, whatever the condition is given, I have already drawn the PV and TS diagram of the system. Here 1 to 2 represent compression, 2 to 3 represent condensation, and 3 to 4 represent throttling, and 4 to 1 evaporation. So here it is written dry at the end of the compression. So here point 2 is on the saturated vapor curve. Okay, so now we have to find out the COP of machine. So we know the COP formula for if the enthalpies are given. So COP is what? What is the amount of refrigeration effect, that is H1 minus H4 divided by compression work. So COP is equal to H1 minus H4 divided by H2 minus H1. Okay, sorry, it is H2 minus H1. So now we will find all the enthalpy values at all the corresponding point. But first of all, we have to find the what is the condition of point 1, because it is in a mixture of liquid vapor state. And here 1 to 2 is isentropic process. So we can write S2 is equal to S1. S2 is equal to what? Entropy of the gas or vapor, saturated vapor at 26.7 degrees Celsius. So it is given as at 26.7, the SG value, S2 is equal to SG value, it is given 4.334. 4.334 is equal to S1 is what? Entropy it is given as S at 6.7 degrees Celsius, SF plus X into SFG, or you can say that SFG is called SG minus SF. So we can write it from this table. I'm directly writing the values over here. That is minus SF, that is minus 0.113 plus X times 4 point. You can refer the table in the question paper given. So I'm not going scrolling up and down frequently. So here if you solve, then you can find out the dryness fraction is equal to 0.92. So now we can find the enthalpy at point 1, that is called HF plus X into HFG. HF is what? At minus 6.7 degrees Celsius, 29.3, and HFG value is also given 1293.8. So it is when you put minus 29.3 plus 0.92 into 1293.8. So you will get enthalpy of one H1 is equal to 1160.99 kilojoule per kg. Okay, now H2 is what? Saturated vapor at 26.7. So directly from property table we can write 1297.9 kilojoule per kg, and 3 to 4 is throttling process. So H3 is equal to H4, it is equal to from the, it is a saturated liquid enthalpy at 26.7 degrees Celsius. So when you see in the property table, it is 125.6 kilojoule per kg. So now put all this value in the COP formula. COP is what? H1 minus H4 divided by H2 minus H1. So H1 is what? 1160.94 minus H4 is 125.6 divided by 1297 point 1297.9 minus, sorry, 1297.9 minus 1160.94. So when you solve this in your calculator, you will find the COP as 7.56. So this is the easiest question that I found in the whole paper, and it consists of 20 marks. So it's very good. and you can say that it's a scoring question. You can easily get 20 marks, and COP answer is 7.56. Next question, that is of a Brayton cycle power plant. An ideal gas turbine engine operates with the air working as a working fluid and the pressure ratio. So here pressure ratio RP, it is 18. And the maximum temperature, here you can see from the TS diagram I have already drawn. So maximum temperature, that is T3, that is 700 degrees Celsius. So T3 we can write in Kelvin. If you want to write, then it is 973 Kelvin. And the air enters in the compressor at 100 kilopascal and 20 degrees Celsius. So here it is at point 1. Air enters in the system at point 1. So P1, sorry, P1 is equal to 100 kilopascal, and T1 is, it is 20 degrees Celsius. So if you convert it, then you can find 293 Kelvin. Okay. Now Cp value is given and gamma value is also given. We have to find the thermal efficiency, heat addition, and the temperature rate of the exhaust gas. So first of all, we will find thermal efficiency. So Brayton cycle thermal efficiency is gained by 1 minus 1 upon pressure ratio power gamma minus 1 upon gamma. Okay, gamma is what? 1.4. Okay, so if you found the value pressure ratio power gamma minus 1 upon gamma, so when you put this all this value over here, so you will get 18 power 0.4 divided by 1.4, so you will get 2.28. Here why I'm finding separately 2.28 over here, because we have to use this value frequently. So put this value 1 upon 1 minus 1 upon 2.28. So thermal efficiency will be 56.21%. This is the first thing that we have to find. The second thing is the heat addition. Heat addition from here 2 to 3 processes a heat addition. So heat addition Q, it is given by per unit mass Cp T3 minus T2. We have given the value of maximum temperature T3, but we don't have the value of T2. So as 1 to 2 is isentropic process, so T2 by T1 is equal to pressure ratio power gamma minus 1 upon gamma, that we know 2.28. So just 2.28 multiplied by 293 Kelvin. So you will get the answer T2 in Kelvin, that is 670 Kelvin. Okay. So put all the value 1.0035 and 973 maximum temperature minus 670. So you will get 378 378.32 kilojoule per kg heat added in the system. So this is the answer of our second question. And now they have given the find out the temperature of exhaust gas, that means at T4. So again 3 and 3 to 4 is isentropic process, so T3 by T4 is equal to pressure ratio power gamma minus 1 upon gamma, so it is 2.28. So T4 is equal to T3 by 2.28. T3 we know 973. So when you divide this value, you will get 426 Kelvin T4. So this is the answer of all the three questions that they have, all the three values that they have, and it is a 10 marks question. This is also again good question. Okay, so you can easily score 10 marks and 20 marks over here. I hope you like this solution, and keep supporting this, like this video, and subscribe this channel for continuing this series of our UPSC Civil Service Mechanical Mains paper. Thank you for watching this video. We will meet tomorrow with new questions.